My name is Maimuna. I am studying first year MPCS. Today I am going to tell the topic characteristics of central force. First, what is central force? A central force is defined as a force which always acts on a particle or a body towards or away from a fixed point and whose magnitude is depends upon only on distance from the fixed point. This fixed point is known as center of the central force. Is known as central force. This is the diagram belongs to central force identification. Next, examples of central forces. The gravitational force exerted on a particle by another particle which is stationary in an internal frame of reference is central force. Next, consider two particles of masses m1 and m2 are separated by a distance r. The force experienced by first particle due to the second particle can be expressed as F12 is equal to minus g m1 m2 by r square into root cap. But actually F is equal to F into r cap. Therefore, F into r is equal to minus g m1 by m2 by r2 is equal to minus c by r square, where c is equal to minus g m1 m2 or f of r alpha 1 by r square. The earth rotates around the sun under a gravitational force of attraction which is central force and is directed towards center of the sun. These examples of central forces. Next, the electrostatic force exerted on a charged particle by another stationary charged particle is central forces. The electrostatic force between two charges Q1 and Q2. These two charges Q1 and Q2 is separated by a distance r is given by F bar 12 1 2 is equal to 1 by 4 pi epsilon naught Q1 Q2 by r square into r cap. But f of r is r cap. Therefore, f of r is equal to 1 by 4 pi epsilon naught q1 q2 by r square is equal to c by r square, where c is equal to q1 q2 by 4 pi epsilon naught. Then, the electron in a hydrogen atom rotates around the nucleus under Coulomb's electrostatic force of attraction, which is central force and is directed towards center of the nucleus. Next, characteristics of central forces. The general form of a central force is represented by F bar is equal to F into R cap, where central force is a conservative force, that is, the work done by the central force is moving a particle from one point to another is depend of the path followed under a central force. The torque acting on a particle is always zero. Under a central force, the angular momentum of the particle remains constant. Under a central force, the aerial velocity of a particle remains constant. The central force is attractive when that is negative or repulsive that positive. Next, conservative force. A force is said to be conservative when the work done by the force in moving a particle from a point A to a point B is dependent of the path followed between A and B and is the same for all the paths of central conservative force. A force is said to be conservative when the work done by the force in moving particle. The work done depends only on the particle initial and final positions. In addition, the work done by the conservative force along a closed path is always zero. Examples are gravitational force and electrostatic force and magnetic force. This followed by depends upon the particle initial and final velocities of position. Is work done by conservative force is along a closed path is zero. Next, proof of the central force is a conservative force. Consider 2 points A and B connected by two arbitrary paths 1 and 2. Let a particle be moving from point A to point B along any path under a central force which is directed away from a point O. Of the proof of the central force is a conservative force is always directed away from a point O. Next, proof of the central force. Consider 2 points connected by arbitrary tubes. Let the diagram is shown below. This is path A and path 2, path 1. This is A from B. This was the directions of R bar and R2. This was the diagram for conservative force in central force. Next, if theta 1 and theta 2 be the angles between F1 and dr1 bar and F2 be dr bar 2 respectively, then the projections of vectors dr1 and dr2 and on F1 and F2 will be dr1 cos theta 1 and dr2 cos theta 2 respectively. From figure, dr1 cos theta 1 is equal to dr2 cos theta 2 is equal to dr. So F1 into Fd1 bar is equal to F2 into dr bar. In this same way, we can obtain the same result by considering every path segment taken along path 1 and path 2. So in general, along path 1 is up to integrate BA into F1 into FDR1 is equal to along path 2 B into B integration from B into A F2 into dr2. Thus the work done by the forces along the two paths is equal. Thus the work done by central force acting on a particle moving from A to B depend of path. Hence central force is a conservative force. The work done is moving the particle from point A to point B through path 1 is given by WA is equal to path 1 integrate B from R F1 into dr1 is equal to integrate BA F into dr. Similarly, the work done is moving the particle from point A to point B through path 2 is given by path 2 A from B F1 into dr1. Path 2 is integrate A from B if F into dr is equal to minus integrate B by A F into dr. Therefore, F A into B is equal to minus WBA or AB plus WBA is equal to 0. Thus, the total work done around the closed path A into B into A is 0. Hence, central force is a conservative force. A central force is one that acts along the line joining the source of the force and the object on which the forces acts. For example, the force F exerted by the sun on a comet, the torque is force is tau is equal to F R into F. Tau is equal to RF cos 180 the angles is equal to 0. The rate of change in the angular momentum of the central force of the comet is dl bar by dt is equal to tau. If tau is equal to 0, dl by dt is equal to 0. Hence is equal to constant. L is a constant vector. Thank you.